Continuing on here in section 4.2, we're going to convert standard form to vertex form. So here we're starting off with standard form, but we want vertex form. And keep in mind, vertex form is y equals a times x minus h squared plus k. It's the one where we can see what our vertex is. So in order to write it in vertex form, we're going to keep our framework here. Now, we need to know what our vertex is to put it in vertex form. So A is going to be 2, B is going to be 10, and C is going to be 7. Our A value we know right away. That's the same whether we're in standard form or vertex form. A is 2, so I can substitute that in for A right away. In order to find our vertex, we start off with our axis of symmetry. X equals negative b over 2a. So negative 10 over 2 times 2. Or negative 2.5. So that's going to be my axis of symmetry. My axis of symmetry is the line x equals negative 2.5. Now, to find my vertex, remember that the x-coordinate of my vertex is always on my axis of symmetry, so it's going to be negative 2.5. To find my y-coordinate, we substitute that in. So I take that x value and plug it in for the x's in my function. So 2 times negative 2.5 squared plus 10 times negative 2.5 plus 7. This is going to give me negative 5.5. So negative 5.5 for my y-coordinate of my vertex. So again, here my vertex is negative 2.5, negative 5.5. Now that I know that, I can plug it into vertex form. Remember, our vertex is HK. So I substitute my vertex in with a negative minus a negative. It gives me a positive 2.5. And then my k value is plus a negative 5.5 or just minus 5.5. So again, keep in mind the red part is our framework. That stays the same every time. The black part is what I substituted in. A, we know it's the same in vertex and standard form. To find my vertex, I used my axis of symmetry, the negative b over 2a. That x value is going to be the x-coordinate of my vertex. I plug that in. Minus a negative gives me the plus here. 2.5. I took that negative 2.5, substituted it into my function, and found my y-coordinate, which is my k value. And this is going to be my vertex form. Now, feel free to pause here and give this a try if you'd like. We want vertex form, so I'm going to start off with y equals a times x minus h squared plus k. My framework, I keep my y's, x minus and squared. All I'm going to substitute in then is my a value, my h value, and my k value. A I can pick out right away is negative 1. You can put the 1 there if you want as well, or just the negative. So again, a is negative 1, b is going to be 4, c is negative 5. We start off by finding our axis of symmetry, and that's found at negative b over 2a. X equals negative b over 2a. It is a line, so we need the x equals there. And my axis of symmetry is going to be at 2. Now that I know the x-coordinate for my axis of symmetry, that's also the x-coordinate of my vertex. Remember, my vertex and my parabola intersect at, my axis of symmetry and the vertex of my parabola are always going to intersect, which means our x values are the same. Now that I know that x value, I'm going to substitute it in. So I have negative 2 squared plus 4 times 2 minus 5. And this part right here, guys, be very careful about. We square first and then multiply by the negative. It's like a negative 1. We said a was negative 1. So exponent first. 2 squared is 4. Then we bring down the negative. And I get negative 1. So when I plug these in, x is 2, my h value here. Remember, this is hk. Y is -1. That's my k value, so -1. So y equals negative, you can put the 1 there if you want to, but you don't have to, x minus 2 squared minus 1. And that is our vertex form because we can pick out our vertex. It's also very helpful for translations as far as graphing. In example 4, the New River Gorge Bridge in West Virginia is the world's longest steel single arch bridge. We can model the arch with the function here, where x and y are in feet. How high above the water is the arch, and how long is a section of bridge above the arch? So we want to know two things. We want to know how high above the water, so we want to know this amount, and we want to know what is the length of the section of bridge above the arch. So we're talking the arch starts here. We're going to go all the way across till we get to the end of the arch here. We want to know those two things. So keep in mind that this arch shape is a parabola. And this highest point, okay, is our vertex. So if we can find out our vertex, we can find out some key information here. And we find that vertex by first finding our axis of symmetry at -b/2a. So here, -0.847 over 2 times -0.000498. It's going to give me approximately 850. And keep in mind that x is labeled in feet. Be very careful when you type this in, guys. Keep in mind that you're going to have to put parentheses around the denominator or multiply that first. Otherwise, your calculator thinks you're dividing and then multiplying. So PEMDAS, we know what we mean, but your calculator doesn't. So you've got to put parentheses there. Okay, so that's my x value. That tells me how far away along my axis we are when that maximum happens. That's my x. Now, to find my y, I have to substitute that into my function. So I take -0.000498 times 850 squared plus 0.847 times 850. We plug it into both spots. And here I get about 360. So again, I took that and I plugged it into my function in both spots. To get my y value, and I got about 360 feet. Okay, that's right here. Or this height is 360. That's the height of our arch. Okay, but we don't want to know what is the height of our arch. What we want to know is how high above the water is it. Okay, we want to know this entire part. So if this part is 360 and this part is 516, I can add those together and it's going to be 876 feet above the water. So again, if they just wanted how high, like above the supports, let's say our supports were here, then it would have just been the 360. Okay, but they wanted how high above the water, so we had to add in the rest of it. That's the distance from the arch to the water. Now, we want to know how long is the section of bridge above the arch. So we're looking for this far, which happens to be the same as this far. And we already said that this much is 850 feet. Keep in mind that parabolas are symmetric, which means if this point is 850 away from where my vertex is, so is this part. So I take that 850 feet times 2 because I have that far on the left and that far on the right, and I get 1,700 feet long. Again, that halfway point here is half the way across the bridge. Okay, we go up to half and we have to go back down that half, which is another 850 feet. So our total is 1,700 feet long. Now feel free to pause here and give this a try if you'd like. The Zhaozhou Bridge in China is one of the oldest known arch bridges, dating to AD 605. We can model the support arch with the function here, where x and y are measured in feet. How high is the arch above its supports? So we're looking for how high. Remember, height deals with our y value. And we want to know at its maximum, so we're looking for the vertex. In order to find the vertex, we need our axis of symmetry. And I find that at x equals negative b over 2a. Here, my b value and remember, our b value is always with our x term, whereas our a value is always with our x squared. So this is my a value here. Instead of a negative or an equals, this should just be a negative. Sorry about that. Now I calculate that. Don't forget again that we need the extra set of parentheses here when you type this in, or to calculate that 2a by itself. And this is going to give me approximately 61 feet. 60.9990697. Now that I know what x is for my vertex, because keep in mind, the x-coordinate for my axis of symmetry is also the x-coordinate of my vertex, so my vertex is about 61. I want to know how high, though. I want to know the y-coordinate of that vertex. So I take my x value and I substitute it in for both x's. And here I'm going to use that second answer key, which is actually like the negative key. So I have the exact value, not the rounded version. But if you use the rounded version, I think it'll still round down to the same thing on this example. Not always, but here I think it should. Yeah, so here I get y to be approximately 3.999953001. And I got that by taking and substituting into my function the 60.9990697 squared, and then my x value again. And I got approximately 4. So my vertex is at 61 feet, 4 feet. That's my highest point, that maximum value. So how high is the arch? 4 feet is our solution. Quick recap here for section 4.2. Any quadratic function is a stretch, compression, reflection, and/or translation of the parent function y equals x squared. The standard form of a quadratic function is f of x equals ax squared plus bx plus c. And for any quadratic function written in standard form, the values of a, b, and c provide key information about its graph. And that's all I have for section 4.2.